Okay, so in lesson 8, we're going to be looking at distance on the coordinate plane. We're going to use a real life example to get an idea of what this is about, and then we will look at some coordinate plane examples. So the problem says 4 friends are touring on motorcycles. They come to an intersection of 2 roads. The road they are on continues straight, and the other is perpendicular to it. We'll see what that means when we make the picture. The sign at the intersection shows the distances to several towns. Draw a map diagram of the roads and use it and the information on the sign to answer the following questions. So the first thing we're going to do is we're going to draw the picture. So if I'm traveling with my friends and I come up to an intersection, it says that the road that I'm on continues straight and that there's a road perpendicular to it. And that just means that there's a road that forms right angles, so right here are the right angles, with the road that I'm on. So if we look at the sign, it says that Albertsville is 8 miles to the left. So 1, 2, 3, 4, 5, 6, 7, 8. Here's Albertsville. We'll put A. Blossville is 3 miles straight ahead. So here is Blossville. Cheyenne is 12 miles ahead, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's Cheyenne. And Dewey Falls is 6 miles to the right. So there's Dewey Falls. So now it's asking us to find the distance between Albertsville and Dewey Falls. So here is where I am. To my left, 8 miles, is Albertsville, and to my right, 6 miles, is Dewey Falls. So in order to figure out how far apart these two are from each other, I would have to take that 8 miles and add on the 6 miles. So I would do 8 plus 6 to get 14. Now it's asking for the distance between Blossville and Cheyenne. So Blossville, remember, was 3 miles ahead of me, and Cheyenne is 12 miles ahead of me. In order to figure out how far they are from each other, I could just count the distance between them, but if I look, since this one is this far from me and this one is this far from me, I can take the two and subtract them. 12 minus 3 equals 9. And if we count, we can prove that. 1, 2, 3, 4, 5, 6, 7, 8, 9 apart. So we're subtracting the two. So now what the difference is, why am I adding for one and subtracting for the other? What it is where they're in location to me. So for Albertsville and Dewey Falls, one was to the left of me and one was to the right of me. So they were on opposite sides of me. So the opposite sides, we added. Okay, and then for the difference then with Blossville and Cheyenne is that they were on the same side of me. So they were both in front of me on the same side. So on the same side, we subtracted. And that's going to come into play, both of these, when we look at the coordinate plane as well. So now this is saying on the coordinate plane, what represents the intersection of the two roads? So if you look, this picture kind of looks like the coordinate plane. And they're asking what the intersection, or where I am, would represent. So hopefully we all know that where the two lines meet is the origin. So that's what that represents. Okay. Now we're going to kind of look and break this down, looking at some points from the coordinate plane. So the question asks, what is the distance between -4, 0 and 5, 0? Well, the first thing that I would do is I would draw a picture of this. So I can draw my coordinate plane. -4, 0 means I'm going to go over -4, x, and up 0 on the y. So x, y, I'm going to go over from the origin to -4, 1, 2, 3, 4, and then up 0. So this is my -4, 0. For 5, 0, my 5 is my x and my 0 is my y. So I would go over 5 and then up 0. Okay, so those are my 2 points. I'm trying to find the distance between them. It's kind of similar, if you'll notice, to Albertsville and Dewey Falls, as they're on opposite sides of the origin. So it asks us, what do the ordered pairs have in common, and what does that mean about their location on the coordinate plane? So if you look at these 2 points, they both have a common y coordinate, which is 0. So we can say they have the same y coordinate of 0. And because it's 0, it puts them on the x-axis, puts them on the x-axis. Remember, we talked about that previously, that if the y coordinate is 0, that means it's on the x-axis. From this, we can see that this line that would form between, if we made a line segment between these 2 points, it would be horizontal. Remember, horizontal goes across just like the x-axis goes across. So it is a horizontal line. So that's something you're going to need to know. If they have the same y coordinate, it forms a horizontal line segment. So it asks us, how did we find the distance between 2 numbers on the number line? So this is referring back to the Albertsville and Dewey Falls problem. Well, when they were on opposite sides, we added the distances from 0. So opposite sides, we add the distance from 0. Now, just a reminder, the distance from 0 on a number line is your absolute value. So in other words, what this is saying is we can add the absolute values of the coordinates from the problem. So when we do this, what we can do is take our 2 ordered pairs. I always find the one that they have in common. So in this case, they both had the 0 in the y coordinate, and I cross those off. I'm not looking at those. That's going to help me determine that it's a horizontal line segment, but I'm really looking at the other 2 numbers to determine how far apart they are. If I take the absolute value of -4, or the distance it is from 0, the distance it is from 0 is 4. So I'm taking that absolute value of -4, and I'm adding it to the absolute value of 5, which is 5. That will give me the distance in units. So they are 9 units apart. Okay, so we're starting to kind of see the trick of how we do these types of problems. We cross off the one that they have in common, and then looking at the signs of the numbers is what's going to help us determine if we're adding or subtracting. So instead of opposite sides add the distance from 0, or the absolute values, we can think of it as opposite signs add the distance from 0. So since the -4 is negative and the +5 is positive, they're not the same sign, so we would add their absolute values. Okay, looking at another example. This one is asking us the length of the line segment with endpoint 0, -6 and 0, -11. So, once again, we can draw a picture. In this case, if we label our x and our y coordinates, we can see both have an x coordinate of 0. And that's what it's asking in this question. So they both have x coordinates of 0. And if you recall from the other lesson, lesson 6, that means they're going to be on the y-axis. So let's just draw a picture of this first. So 0, -6 means I'm not moving over any on the x-axis. And on the y-axis, I would be going to -6, which would be below 0. So I would go 1, 2, 3, 4, 5, 6. Right here, that's my 0, -6. For 0, -11, again, I'm not moving over at all on my x-axis, but I would move to -11, which again is below me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's my 0, -11. So if we were to connect these to make a line segment, we can see that line segment is a vertical line segment. So if they have the same x coordinate, they make a vertical line. So remember we saw previously if they have the same y, it's a horizontal line segment. If they have the same x, it's a vertical line segment. One way I remember that, just to give a little hint for that, is that x, so if they have the same x, in the letter x, it makes the letter V for vertical. If they have the same y, you can make a y kind of look like this, and if you think about that, y upside down kind of looks like an H for horizontal. Just a little trick that may help you remember that. So now, what we're going to do is think back to what it means with what we saw previously. This is very similar to Blossville and Cheyenne. They were on the same side of me, and in this case, they're on the same side of the axes. So, same side, which I'm going to change to same sign, we're going to subtract their absolute values for their distance from 0. So, in this case, the quick method, if I have the points 0, -6, and 0, -11, they both have the same x, so I'm going to cross off the zeros. Their y's are different, and if you look, they're both negative, so they have the same sign. So now what I can do is I can find the absolute values of these numbers and subtract them. I want to put the one that's going to have the larger absolute value first. So the -11 is going to have a larger absolute value than -6. So I would do the absolute value of -11 minus the absolute value of -6. So that just says I'm going to do 11 minus 6, which means they're 5 units apart. If we count from here to here, we can see 1, 2, 3, 4, 5 units apart. So this method will work. Okay, so now this is one where they're not going to be on the x or the y axis. And again, it's the same idea of what we were doing. So I'm going to kind of show you that quick method. So I'm going to kind of ignore some of these questions up here and just show you the quick method to doing this. So I always like to label my x and y coordinate above the ordered pair. Looking at the two ordered pairs, what they have in common is their x. They both have -3 as their x coordinate. So what this says about the line segment, if they have the same x coordinate, that means it's going to be a vertical line segment. Remember we said same x makes that V for vertical. So this is a vertical line segment. And now, to find how far apart they are, we would look at the y's since they are different. So I have +3 and I have -5. These are not the same sign. They're different signs. One is positive, one is negative. Different signs means I'm going to add their absolute values. And I remember this because different starts with D and there's D's in the word add. If they were the same sign, like the previous one, same means we're going to subtract their absolute values. Same and subtract both start with S. So when we're adding, it doesn't matter which order we add them in. I'm going to find the absolute value of 3, and I'm going to add it to the absolute value of -5. So the absolute value of 3 is 3. The absolute value of -5 is 5. 3 plus 5 tells me these 2 points are 8 units apart. Okay, so in problems like this, you start by finding what they have in common. That will tell you whether it's a horizontal or a vertical line segment. If the x's are the same, it's vertical. If the y's are the same, it's horizontal. Then, after you've found the one they have in common, I like to cross them off because I find that to be easier. And then you look at the other coordinate. If they have the same sign, so either they're both positive or they're both negative, you're going to subtract their absolute values. If they're different signs, like in this problem, you're going to add their absolute values to find their distance. The next piece of your notes just basically breaks it down and tells you exactly the steps to doing this. So it tells you cross out the similar coordinate, look at the coordinates that are not the same, and if they have the same sign, you're going to subtract. If they have different signs, you're going to add. And then it also tells you about the vertical versus horizontal. X is vertical, Y is horizontal. Again, X has the letter V in it for vertical. Y is basically an upside down H for horizontal.